multiply and divide positive rational numbers fluently is something that we learn in 6th grade. We're going to start by reviewing a little bit before we jump into a problem. Let's take a look at working with decimals, which are positive rational numbers. So when we multiply decimals, you multiply them as you would whole numbers. We have to look at the number of decimal places, and we then use the number of decimal places added together to place our decimal in the answer. So what does that look like? If I have 8/10 times 9/10, I would say 8 times 9 is 72. I look at the decimal places, so I have one decimal place and one decimal place in my problem, so that's a total of 2 decimal places. So then I know to place my decimal, I have to move it 2 places, and I'm going to place it 2 places from the right. So 72 hundredths is our answer, which when you think about it makes sense, because if we took tenths times tenths, we would get hundredths. Let's take a look at dividing 2 decimals. If I want to take 1 71 hundredths divided by 9/10, I could estimate and say, well, that's about 2 divided by 1, which is going to give me about 2. But to really find the exact answer, we're going to first move our divisor's decimal so that we are dividing by a whole number, because we wouldn't have groups that are parts of a group. So we want to work with a whole group. Multiply by 10 to make the whole number, I have to do the same thing inside here. So when I move my decimal place 1 to the right, that's like multiplying by 10. And I do the same thing. So now we have 9 as our divisor, and we're dividing that into 17 1/10. So 17 1/10 divided by 9. So then we divide normally. We place the decimal and we look to see how many 9s will go into 17. 1 times 9 is 9. I subtract and I'm left with 8. I bring down my 1 and I recognize that 9 times 9 is 81, and I have no remainders. So my answer is 1 9/10. Hey, that checks out. That was pretty close to 2. And we can work it backwards and multiply 1 9/10 times 9/10 to get our original. Multiplying and dividing fractions is another part of our positive rational numbers. So we've got to work with multiplying fractions. When we think about multiplying fractions, we want to think about multiplying the numerator times the numerator over the denominator times the denominator. So here we have 2/5 times 4/7. That's like saying 2 times 4 in my numerator and 5 times 7 in my denominator, which is going to give me 8 over 35. Because 2 times 4 is 8 and 5 times 7 is 35. If you were to have a mixed number, like 3 1/2, before you started multiplying, you may want to change it to an improper fraction. Dividing fractions is really the same as multiplying by the reciprocal. So when we divide fractions, we're going to take this second fraction and we're going to multiply by its reciprocal. The reciprocal means that we're going to switch places with the 5 and the 7. So it's like it flips over. So we would end up multiplying 2/3 times 7/5. Notice how the denominator is now in the numerator and the numerator is in the denominator. Now we're back to what we did with multiplying fractions. We just need to take the numerator times the numerator and the denominator times the denominator. So we end up with 14/15. Let's take a look at a problem that applies multiplying and dividing positive rational numbers. At the party, Jack's mom divided 73 8/10 ounces of candy equally among all the kids at the party. If each kid at the party received exactly 4 1/10 ounces of candy, how many kids are at the party? And we see we've got answer choices 18, 16, 15, and 4. So we got to make sense. What are we being asked to do here? If each kid at the party received 4 1/10 ounces of candy, how many kids are at the party? So we need to find out how many kids are there. So they've given us some hints. They told us that we started with this 73 8/10 ounces of candy. So I have this large amount, and she divided it into groups that contained 4 1/10 ounces of candy. So we need to figure out how many of these smaller groups we have that would divide equally so that we would get the number of kids that were at the party. Some clue things in the problem said that they divided among the kids. Each kid at the party received exactly the same amount. So I know that this is going to be a division problem. I also know I've got decimals and I got fractions. And I really want to work with either all decimals or all fractions. In this case, 4 1/10 is really a nice, easy fraction to convert. 4 1/10 is the same thing as 4.1, 4 1/10. So I'm going to take 73 8/10 and divide by 4 1/10. Remember, if we have a decimal in our divisor, we need to make that a whole number. So we're going to move that decimal over 1 by multiplying by 10. It moves it 1 to the right. And then I would place my decimal where it would be in my answer. So now I can divide 41 into 738. Well, I can actually get a group of 41 out of 73 first. So I can get one group. When I subtract, 1 times 41 is 41, and then subtract, I get 32. I bring down my 8, and now I'm looking at 328, and I've got 41. And I'm kind of going to estimate this because I don't want to have to like make a list and go 41 times 2, 40 times 3, 41 times 4, etc. I recognize this is about 40 and this is about 320. Well, 8 times 4 is 32. So that's where I'm going to start. I'm going to see if 8 will give it to me. So 8 times 41, 8 times 1, 8, 8 times 4, 32. So now I'm subtracting 328 from 328 and end up with 0, no remainders. I think I've got my answer here. 18. There are 18 kids at the party. Looking at my answer choice, I see that answer choice A is 18. So I've found my answer. But when I was looking at some of the others, I can see that I could have crossed out 4 right away. Because if we think about it, 4 times 4 is 16. That's not going to be anywhere near 73. So this was one that I could cross out. But I really did need to do the division because 15, 16, and 18 are all pretty close together. So let's check our work by now multiplying 4 1/10 times 18. So 4 1/10 times 18 gives us 73 8/10 ounces, which is what we started with. So we know there are 18 kids at the party.